Okay, in this we have front and the top views given to us. We have isometric view to be sketched on this particular grid paper. The front view being this one, the top view over here. The first step, as discussed in the previous video, it would be to determine the overall size, maximum width, maximum depth, and maximum height. So it's given by a unit cell here, and they are about 11 units across the width. We have 7 units across the height and 5 units across the depth. The picture isn't that clear, but it's been carefully identified by counting the number of units here, like 3, 4, and 5. In the same way, if you go along the width, it will be 11, and in the height, we make use of this as references 1, 2, 3, and so on. So begin with the coordinate triad. These are the coordinates. We start somewhere from the bottom right side corner in this region, so that we'll have about 11 divisions in this side, 5 divisions here, and 7 divisions on the top. Sorry for that. Let me start from this point. So 1, 2, 3, 4, 5 divisions along the depth. 11 divisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 along the width, and a height of 7. 1, 2, 3, 4, 5, 6, 7. Try to make the bounding box now. Right, the right face is done. We go in by, so I'm going to follow this over here. This is along this point here, so that's the one. We now try to add the surfaces that belong to these three planes or three faces. In the front, we have got a surface here. This is one surface bounded by these contoured lines. This is the second surface, and this is the third one. There is a circle and a region inside. This is basically a cut as seen from the top view, that it is a hidden line in the top, indicating it's a drilled hole. So there won't be anything to be sketched in here except for a shape of a circle that goes on this face. So these three surfaces, of these three, we need to know how many of those lie on the front face. Next, we have the top view. So the top plane is available here. So of the surfaces shown in there, this is one on the left with the solid line. This is the second one bounded by this region. And so of the two, the left one would belong to the top, as can be seen from the top edge. So we now try to first figure out the surfaces, the location on the bounding box. So in the front view, this is the surface when projected up along the construction lines here would be along this horizontal line. It's a normal surface when seen from the front view. So that is the one that goes over here. The other one, second, what we see here, as and when it gets extended with the construction line, it belongs to a inclined line in the top view. So this is not going to lie on the front face, but on another plane which is at this angle. We have a small short horizontal line, and this short horizontal line is parallel to the frontal face. So you need to have another plane at that depth parallel to it, and the shape of that surface would be resembling the one below here in the front view. Now the surfaces that are on the top, the first one, if I come along the ends of this and match it with the horizontal line above, that's the whole surface above here, representing a horizontal line which belongs to the top face. This is the topmost surface on your block, the highest level that you have here. So this is going to be in here. The second surface as a region bounded by these lines here, It's when extended down from the ends of it, it belongs to an inclined line, referring to an inclined surface. So that is going to be on another inclined surface here, which is not indicated as of now. Let's begin directly sketching this surface and the one above that. So this is 1, 2, 3, 4 units. So 1, 2, 3, 4 units. We are done with all what we have on the top. Let's do the front face, surface on the front face. This is going in by 1, 2, 3, 4, 5, 6, 7 units. So this is 1, 2, 3, 4, 5, 6, 7 units. And I don't know exactly where will this end. The height isn't given to us. It's not clear. It's ending somewhere between the two grid lines. So we will get that when we sketch this inclined plane. So we're going to sketch the inclined plane for now. And before that, we have the surfaces that belong to the right face. So the right face, we see that as a vertical line in the front view, and as another vertical line here giving the depth in the side view. So this is how deep 2 divisions. So you're going to come in here from the back end 2 divisions. You're going to raise it up by 3 divisions, 1, 2, 3. So rise this line all the way 3 divisions up and close this to form a rectangle. Okay. Two divisions. You're going up 3 divisions. Now we have the endpoints. We can create a new plane, which will be from the top edge, from this edge to this edge. This is where the inclined plane belongs to. So we have the reference here as this line over here, and the other one that we have as this edge. So let's create it with a freehand sketch between these two. Okay. We come all the way to the frontal plane, and here we get the endpoint and draw this in the front plane as another line. So that's a second plane, and we are going to now add the height for the surface in the front view. Okay. This goes all the way up until it strikes this red color line which belongs to the inclined plane. Connect this back up there to the top face. That's the first surface from the frontal view, which is complete. This is complete. We are now having another face coming in here as a vertical line in the top view, which is referring to the depth and the height of which is shown here in the front view. So this is by 1 division that we need to go in. So let me create a plane for that, for understanding sake of understanding here. This is this is the plane, and we would have the line as a straight line by 1 unit, and it would come down all the way. So we select this as a thick dark line, as it is a solid edge. We need a reference line. This is not ending on the blue grid line, so let me create another reference line for this with the same yellow color. It's going to be parallel to the existing blue line. is what we will follow to sketch the visible edge. Okay, so we have reached until this point. To get this end point of this, we need to cover the horizontal line. This horizontal line is referring to the face, parallel frontal face that appears in here. So we need another plane inside. This is going to be positioned at this particular point going up here. That's the plane on which we have to sketch this. This is we can sketch the two lines at the bottom but not the top one, which belongs to the plane. So for sketching that, we would need an additional line, the red one. So I will try to sketch that guideline first. So we have two divisions from here. So we come in by two divisions from there and connect a line in the top plane. And now we get the end point. This is the end point where we will have the line coming up all the way and then connecting here. This is where it should go up and connect at this point, and this is the corner when seen from the top over there. So this line, which is at an inclination, will be seen as a horizontal line, as a foreshortened line in the top view. Alright, this is now complete as a parallel frontal face. We just need to connect the 2 points on the top here and the 2 points at the bottom to generate this inclined line, as well as this surface which is inclined to the frontal plane. Or you create a new plane and then connect these. For the plane, this is in the bottommost plane. It has to be extended all the way to the top. So I can come in here. This is where we have it meeting the top. This, when extended from here, merges here, and then we are going to connect this line in the top plane. And that's the plane. This is the region bounded by the plane on which the surface is going to lie. So we have the visible lines which will be connecting from the top to the top and from the bottom in here in the same plane. To complete this, there is a line which we missed out behind, which is for the top inclined surface. So we have finished with the two surfaces in the top, the one over here and the second inclined surface. Frontal face is this, which is covering this region. This is where we have this part here, and the other two, which is represented by these lines here, vertical and horizontal, are represented by these two surfaces. The surface here not shown here as a right side view, but we do get it from this information. So let me close this with a solid line on the side. Lastly, we are left with the hole that is to be drilled in here. It is at a 3 distance by 3 unit. So this is 3 by 3 as the center point, and then a 1 unit for radial distance. So we first locate the center point with an axis. This is the axis. So 1 2 3 1 2 3. This is our center point. The bounding box, what we have here is This is the parallelogram. The circle, which is seen as an ellipse, would be within this particular parallelogram, touching the sides at the midpoints and being tangent to all of these 4 points. This could be sketched as a small arc. I'm doing it with a thin line. Later it can be made dark, just to make sure that we'll have a smooth curvature. The same thing to be darkened to a level of the same line thickness as that of all other visible edges. This completes your isometric sketching when given two orthographic views.